one thing. So let's just go through our blanks first. If the terms of a sequence are added up, the result is called a... I think so. Yes. I don't know where it went, but anyways, if the terms of sequence are added up, the result is a series. Remember, that's where a sequence becomes a series. We will use sigma notation to represent the, what does that S stand for? Sum. The mathematical symbol, does anybody know what this Greek letter is? Sigma. Oh yeah, I guess it's right there. Sigma is used to denote a series. It acts as a generator of terms which are then added up, or summed up if you want, I don't know, added, probably easier. So what this really means is Sn is the same thing as this kind of scary looking symbols. But essentially what it's doing is it's telling you what the first symbol is that you're plugging into the T up to the end. So for instance, if you start at 1 goes in there and you have term 1. Then the next one, term 2, 2, 3, 3, 4, 4, and it goes all the way up to n. The top is the ending. So we'll see how this works. Watch this. So we're starting at 1 and we're plugging it into k until we get up to 4. Not the value is 4, but we're subbing in 4. So first one goes in there, we get 1 squared. Because this is sigma, that means we're adding. It's not just a sequence. Then the next one after this is 2 squared. Then 3 squared. Then 4 squared. And then we evaluate this either on our calculator or we can do it in our head. And what do we get? 1 plus 4 plus 9 plus 16. 20 and 10 make 30. This means plug in 1 for k to get a value, then plug in to 2 for k and so on until 4 for k, finally add the terms. That's all it means. So let's plug this in. So we're starting at where x is 1. Notice I changed the variable. It doesn't matter what the variable is. That's why it's a variable. It can be any letter. So we're plugging 1 in for x all the way up to where we get up to 6. So negative 1 to the power 1, it's going to be add, plus negative 1 to the power 2, plus negative 1 to the power 3, plus negative 1 to the power 4, plus negative 1 to the power 5, plus negative 1 to the power 6. Okay, this is where some people struggle on the quiz. They don't understand what the brackets actually mean. This means the whole thing is to the power 1. So do I get negative 1 or positive 1? Negative 1. This means the whole thing's to an even power. So we're going to get positive 1, then negative 1, then positive 1, then negative 1, then positive 1. So negative 1 and a positive 1 cancel, 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 and what do I get? 0. 0. Okay, you guys want to try this one? Oh my gosh, okay. So this time we're starting at 0 where I is 0 and we're plugging it in. So if I plug in 0, what do I get? 1 over, what's 0 minus 1? Negative 1, so 2 to the power negative 1. Plus, then I'm going to plug 1 in. And I get 1 minus 1? 0. So I get 1 over 2 to the power 0. Then I plug 2 in. I get 1 over 2 to the power 1. Then I plug 3 in. I get 1 over 2 to the power 2. Then I plug 4 in, and that's when I stop. And then I evaluate. Now here's the kicker. What is 1 over 2 to the power negative 1? How do we learn to evaluate that? If we have a negative exponent, what do we learn to do? Move it to the top, so then that makes it 2 to the power positive 1, which makes it 2 plus, what's 2 to the power 0? What's 2 to the power 0? 1. What's 1 over 1? 1. And then we have plus a half, plus a quarter, plus an 8. So we have 3 plus a bunch of fractions. So I'll show you, well, how should we do this? Yeah, but I would actually multiply, put this together. And then, yeah, I would probably get a common denominator of 8. So that's what, 4 over 8 plus 2 over 8 plus 1 over 8 gives me 7 over 8. So I get 3 and 7/8, which we haven't used mixed numbers since we're in grade 9. So change it into improper. 3 times 8 is 24, and 7 make 31 over 8. You could have changed this into denominators 8 at the beginning, but there you go. What do you think about sigma notation? It looks confusing, but it's really not. So the sum of T1 r to the power k minus 1 is the sigma notation that will generate a geometric sequence. However, it will not help us find the actual sum without adding up the terms. So we're going to do, I don't think this is our first proof, but we're going to do a proof of how to actually figure out the sum. I gave you the formula here, but I'll show you where it comes from. So if I have the sum formula, which is the first term plus the first term times the ratio plus the first term times the ratio to the power 2. Does everybody see how I'm getting this until I get up to the Tn term? Yes? And then I multiply this by r, so then I get that. Everybody agree? How do I get r to the power n there when I multiply by r? Remember, I add the exponent, so if I'm adding r to the power 1, multiplying r to the power 1 times r to the power n minus 1, the 1s will cancel and I get r to the power n. So now that I have both of these equations that are true, I'm going to subtract it. So you might say, how do you subtract that? Well, you get Sn subtract Rsn. So what happens when I subtract this? Does everybody see that this term will subtract that, and 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 what am I left with?
What?
Term 1 plus term 1 r to the power n. Yes, so now I'm going to do a little bit of factoring. So I'm going to factor out the Sn here, and I'm left with 1 minus r. And I'm going to factor out a T1 here, and I'm left with 1 plus r to the power n. And then last step, I'm going to divide, and I get my formula. Does everybody see if I divide both sides by 1 minus r, I'll get that formula right there? Oh, sorry, I have a little symbol missing there. Try that again. This should be minus because I'm subtracting, right? Does everybody, nobody caught that? Because I'm subtracting here. So this minus this will give me that, right? So there we go. So anyways, again, you don't have to memorize this. You don't have to memorize how to get the proof. I'm just showing you where it comes from. So this is the sum of a geometric series. So if I want to add up 100 terms, I would use this, right? Okay, so let's use it. What's the sum of the first 12 terms? So, sum of 12. Now, the hardest thing is knowing it's a geometric sequence versus an arithmetic sequence, because then you'll choose the wrong formula, right? Like, you can't choose the geometric formula and use it for an arithmetic, right? So what's happening here? Huh? Yeah, r is minus 2. It's not a common difference. It's an r. Well, that should be the clue that you can't use a formula that doesn't have an r in it, right? So we're using the formula Sn, and actually, I'm going to put the formula on the board here. So, Sn equals T1, 1 minus r to the power n over 1 minus r. So, S12 is the first term. What's the first term? 5 times 1 minus, oh, now here's where people will make a mistake because it subtract, oh, watch, it's not plus because it's minus minus, it subtract negative 2 in brackets to the power n, which is 12. all over 1 minus minus 2. Now on the bottom here, that would be minus minus. But do you see on the top here, you actually have to evaluate the ratio to the power 12 first. So it's going to be a negative afterwards because a negative 2 to the power 12 is going to be positive, and a positive and a subtraction sign will give an overall minus, right? Very, very important that you don't screw that up. Okay, so then I get 5, 1 subtract. If I evaluate negative 2 to the power 12, you should know from back in the day that a negative to a power 12 gives you a positive. So even if your calculator tells you something different, it's because you punched it in wrong. You didn't use brackets, right? And negative to the power 12 gives you 4,096, and it's still subtraction because of this subtraction symbol right there. Do you see that? Over 1, now this one doesn't have an exponent, so I can actually evaluate 1 plus 2. Yes? So what's 1 subtract 4,096? Your calculator probably can do all this in one step. So you get minus 4,095 divided by 3. Punch it all in. What do we get? Negative what? Did anybody get something different? Because, yeah, I got negative 6,025 as well. Oh, yeah, you got to divide by 3. That's your mistake. Yes, for sure. Okay, did everybody get negative 6,825? Alrighty. Okay, so we're going to find S6 here. So, what's my ratio? What's my ratio? Well, the way to calculate it is take the second term and divide it by that. You know, it's not 3. It's not just 1/3. It's negative 1/3 because the signs are alternating, right? So you must be multiplying by a negative. Again, just to refresh your memory, R is negative 27 divided by 81, or 9 divided by negative 27, or negative 3 divided by 9. Do you see all of those? I'll get negative 1/3 out of it. So don't get the wrong answer by saying the ratio is 3, because it's not getting bigger, it's getting smaller, right? So technically you're dividing by 3, which is the same as multiplying by 1/3. Okay, so we're finding S6. What's my formula? The first term, which I know, 81. Right? 1 subtract. Yeah, make sure you have it in bracket. Negative 1/3 to the power of 6 all over 1 minus negative 1/3. Are we good? The easiest way, if you don't have a fraction key on your calculator, is just do 3 to the power 6 and get that, and then put 1 over it, right? I would suggest not using calculator for the whole thing then, because there's so many rooms for error for all the brackets. So I would just say 81, 1, now it's going to be subtract 1/3, or negative 1/3 to the power 6, 1 over 729, okay? And then this is 1 plus 1/3. So then on your calculator, I would use my fraction key to evaluate 1 subtract 1 over 729. So then you get 81. Does everybody know how to use their fraction key to do that? Just go 1 subtract 1 divided by, or 1 ABC, depending on what calculator you have, 729 equals, and you'll get a fraction answer. And the graphing calculator paper will have to convert that decimal back to a fraction. So then you get times 728 over 729. And then on the bottom, if you go, like, you should know it's 1 plus 1/3 is 1 1/3, which is 4/3, or you can use your calculator. It's up to you, whatever. So then now if you punch this into your calculator, you don't have to worry about a bunch of brackets. It's just 81 times 728 over 729 divided by 4/3. So what did I say the answer was again? 182 over 3. 182 over 3. Okay, so I will help whoever needs help. Okay. So, yes. So we're going to plug in one. The problem with using the formula, though, is we don't know what the ratio is. Does anybody know what the ratio is by just looking at it? Yeah, it's 2. But say you didn't know, all you'd have to do is come up with the first couple of terms, and you can see that you're doubling it each time, right? So my ratio is 2, but what's my first term? It's 3 times 2 to the power 1, so it's 6. So you actually have to calculate it. And again, if you don't know the ratio, calculate the second term. Put 2 in, so you get 3 times 2 to the power 2, which is 3 times 4, which is 12. And then you can see that 12 divided by 6 is 2, right? So it's not like it's hard. You just need to know how to use that sigma notation. So then if I want to find the sum, how many terms am I adding up here if I'm going from 1 to 25? I heard 25, I heard 26, I didn't even hear 24. Usually people say 24. What's the correct answer? No, 25. 25. So again, use your fingers and say how many are from 1 to 5. There's 5. 1 to 5 is 5. So 1 to 25 would be 25. Yeah. So we're finding the sum of 25. If it was 0 to 25, then it would be 26, right? But the biggest mistake people make is 1 to 25. They just subtract 25, subtract 1 and get 24, but that's not correct. It's like I say, if you read pages 1 to 3, how many pages did you read? 3, not 2, right? Yeah? Okay. So the first term is 6. 1 minus, we don't need a bracket here because my 2, which is the ratio, is positive. So it's 2 to the power 25 over 1 minus 2. Honestly, I would just punch this all in because it's too big otherwise. So punch it all in and see if you get this. You get 201,326,568. Did anybody get that? So I'll give you a second to figure that out. Sorry, I must be dyslexic. This is 86.